In this part, we will continue conducting hydrologic modeling using the HEC HMS program for the gridded option. And after we finished inputting the data and parameters for the sub-basins, dams, junctions, water treatment, reaches, and the data for meteorologic models, we start the implementation of the simulation in the HEC HMS program. So we go to the control specification. Then we press on the gridded HMS run control. Then we specify the date and time for the simulation according to the date and time of the available observed data. So in the start date we type 1 January 2003 and in the end date we type 31 July 2004 and in the time interval we choose 1 day. Then we go to the drop down menu at the top and we choose run a gridded HMS run. And before we making computations, we preview the notes of the HEC HMS program and we read these notes. Then the third note tells us that the basin model laser zap contains one element with no downstream connection R550. Then to treat this note, we go to the reach R550 as we see. Then we specify the downstream for this reach R550, which is the junction J327. So we go to the reach R550 and in the downstream we choose the junction J327. Then by pressing on any menu we find that the order of the elements such as the sub-basin, junctions, reaches and dams were changed for the project in the basin model in HEC HMS program as we see. Then we save a project by pressing on save. Then we close the HEC-HMS. Then we open the project in the HEC-HMS program again in order to preview the changes on the project after connecting the downstream of the reach R550. So we go to the open project, then browse desktop, graded HEC-HMS. Then we select laserzap.hms. Then we go to the basin models, then laserzap, then a new tree for the order of the elements in the study area basin appears as we see. Now we start the implementation of the simulation in the HEC-HMS program. So we go to the control specifications, then we press on the graded HMS run control, then we specify the date and time for the simulation according to the date and time of the available observed data as we see. Then we go to the drop down menu at the top and we choose run graded HMS run. Then we preview the notes of the HEC-HMS program, and as we see the note that told us that no downstream connection for the reach R550 disappeared. Then we press on the compute all elements. Then the red error messages appear indicating that the sediment load gauge is not defined for the receiver Docan, and the sediment load gauge is not defined for the receiver depth. And the reason for these errors is in the selection of the sediment method. So we go to the Docan dam, and in the sediment method, the selected method needs the sediment gauge, and it is not available in this project. So we return to the sediment method and we choose complete sediment trap. Then we go to the depth dam, and in the sediment method, the selected method needs to the sediment gauge, and it is not available in this project. So we return to the sediment method and we choose complete sediment trap, and this method does not need the data. Then we go to the control specifications. Then we press on the graded HMS run control. Then we press on compute all elements. Then another red error message appears indicating that the loose rate parameters are invalid for cell X312, Y1982, and in sub-basin W2140. And the reason for this error is in the sub-basin W2140 that we choose graded soil moisture accounting SMA for the loose method, and the inputting grid for the loose rate in this method does not cover all the area in the subbasin W 2140. So we change the loose method in this subbasin to the SCS curve number. Then we go to the loose menu, and in it we need the initial abstraction in millimeter, curve number, and impervious in percent, and these values had calculated in the HEC-GeoHMS project as explained in the previous videos parts of the category or playlist titled HEC-GeoHMS. And these values exist in the table of the subbasin 1 layer, and in it we have the curve number in the basin CN field, impervious layer percent in the PCT IMP field, and the initial abstraction INIT ABST. So for the subbasin W 2140, the curve number in the basin CN field for this subbasin, which is W 2140, is 97.99 or 80. And the impervious layer in percent in the PCT IMP field for the subbasin W 2140 is 35.46. And the initial abstraction in the INIT ABST field is 5. Then by rerunning the project several times, by pressing on the compute all elements, the same error appears for some other subbasins in the study area basin. So we treat these errors for some other subbasins as we treated it in the previous subbasin W 2140, as we see. Now, after we had created the error, we run the project for the gridded option by pressing on the compute all elements. Then the simulation starts. Then we press on the close. To preview the results, we go to the results menu. Then we choose simulation run. Then a gridded HMS run. Then we choose a global summary. Then the simulation results appear as we see. Then we go to the sub-basin W2140. Then we press on the graph which contains the discharge from 2003 to 2004. Then we preview the other results as we see. Then we preview the simulation results for the dams as we see. Then we go to the junction J308, and in it we preview the results by pressing on the graph. Then a comparison graph of flow in cubic meter per second appears between the observed flow and the resulting outflow, which appears to be approximately and identical. Then we go to the summary table, and in it the results in the computed results and in the observed flow appears to be very identical. So these results for the gridded option are more identical than the non-gridded option. Then we preview the other results as we see. Then we go to the reach R2680, and in it we preview the results by pressing on the graph. Then the comparison graph of flow in cubic meter per second appears between the observed flow and the resulting outflow, which appears to be approximately identical. Then we go to the summary table and in it the results and the computed results, and in the observed flow appears to be very identical. So these results for the graded option are more identical than the non-graded option. Then we preview the other results as we see. So the results for the graded option seem to be accurate and more identical than the non-graded option, which was calculated in the previous parts of the previous videos of the category or playlist titled HEC HMS as we see. And we will continue the implementation in the next parts. Then we save the project by pressing on save.